Hi Arya.
Yes, sir. Good evening. So, how's your day?
Good evening, good evening. Yeah, it was good. It was holiday, so more work.
All right. Hey, morning. Good morning.
Hi, Arya. Good evening.
Sure then. So, did you get the chance to like look at the summary of yesterday's session? Maybe.
Sorry, come back.
Like, did you get the chance to like explore the yesterday's
No,
session?
no, could not. I could not able to see. I will use this weekend to see the recording.
All right. So, you already know you are familiar with Python, right? The fundamentals of Python, maybe the data types.
Uh, you can just give me brief on like what we discussed, like tuples, dictionary, those things discussed, and anything else.
Yeah. Again, the set and list. So, what are the operations that could be performed on these particular data types?
Mhm. Mhm.
So we just
Like
explored with like all the available operations that could be done.
okay. Like when we talk about list, like adding a list, deleting, addition,
Yes,
deletion.
yes,
Okay.
yes, yes. So then,
Split, splice, all those things discussed or like yet to be
not yet.
discussed?
Split and slice. No, we haven't discussed it yet. So yeah,
Okay,
we will
okay.
be discussing it today, and all the nested
Okay,
data
okay.
types.
Okay,
We'll be
okay, okay.
discussing it. Okay.
Okay.
So then, let's start. I will just share my screen. Please confirm if it's visible. Is it visible?
Yes, we can see.
Okay, great. All right. So yesterday we checked on like what are the basic data types, primary data types, and the complex data types we have in Python, and what's the fundamental difference between all those, and how to define those. Okay, and the operations that could be performed on those particular data types. All right. So today we'll be exploring on like we'll be exploring more on these data types, but not at a fundamental level. Okay. So let's just consider, so most of the time we will be using list and dictionary the most. Okay. So yeah, considering the list, the elements of the list could be like primitive data types like integer or one, let's say ABC string. Okay. And it could also be some object. Again, everything in Python is object. So this one is nothing but it's integer, but it is also an object of integer, correct? So there is some class called integer. Okay. This one is particularly an object of integer. Okay, so this is an object. Again, string. It is an object of like a string class, right? So this is also an object. So similarly, since these two are we are considering it as object. So here, let's just say there is another list. List is also an object of list class, correct? So the first element is one. The second element is ABC. The third element could be another list which contains much more elements. Doesn't matter, correct? So the fourth element could be another list or tuple maybe. The fifth element could be like some set or dictionary. Okay. When we say different types of data types are allowed within the list, right? So we actually doesn't mean it's only about primitive data types. It also means a list can contain another list. It can contain other complex data types like set, dictionary, or tuple. Understandable? So let's name this. So the first element is A. The second element is maybe a list which contains A, B, C as its element. Third element of this list is could be like let's just say one. The fourth element could be let's just say tuple, which contains one comma two. Okay, this is a list now. A is a variable. Okay, this is a variable which references to a list, and these are the elements within that list, right? So let's just say we are calling like at the index 0. The first element is index 0. So zeroth element means, so zeroth index element means first element. The second element is first index. Okay. The third element is second index. It's more like n minus 1 is the index of that particular element within that list. So when we call for like, let's just say print of a of 0. Okay. this actually prints for A, right? So this is the first element. So let's say there is print of A of 1. Okay. So this actually means the second element of this particular list, which is reference to A. Okay. So here the second element is this ABC, another list. So this will print another list which contains elements like A, B, C. All right. When we type up a code like print A of 2, okay, this actually means the third element at the tool's second index. So here it is only 1. This actually prints 1. Right. And similarly, for A of 3, that is at the fourth index, sorry, third index, that is the fourth element, it prints tuple 1, 2, right? Understandable? Okay, Saurabh?
Yes, yes.
Yes, yes.
Yes. So yeah, so when we say different data types are allowed within the list data type, we essentially mean it could be primitive data type like it's integer, float, or string. It could also be like complex data types. All right. So that's what I wanted to explain here. Let's just a second. Am I audible, guys?
Yes, yes, yes.
Sorry, I lost it there. Yeah. So let's just open the collab we were experimenting with yesterday. So let's create another block. Let's say some list one. Let's just say L1 is our list. Okay. Here the first element is 1. The second element could be ABC. The third, okay. The third element could be another list which contains like 1, 2, 3, 4, maybe. Right. The fourth element could be some set. Let's just say it has parameters like 3, 4, 5, 6. Okay. And here, let's just say there is another dictionary. The fifth element is the dictionary. It has got a key value here. That's, let's say, name. Name has got, let's say, Arya. Okay. Session. So let's say this is AI quality engine. All right. So let's just run this. So yeah, Saurabh, we are
Yes.
using Google Colab as we said
Colab. Yes,
yesterday.
yes, yes. Yes, yes, yes.
So
How
did you
can I get
experience
this
this?
link? How can I get this link today?
Okay. Okay. You
Uh,
can link to this particular notebook, or basically you want to open the Google Colab.
okay, okay. If I open Google Colab, is there a link to connect with your page or how?
Yeah,
Okay,
I can share this page later in the chat.
okay, okay,
Okay.
okay, okay, okay. Okay, got it, got it.
And yes, let's just print L1 for now. So Manokdev, yesterday we just put up primitive data types 1, 2, ABC. That's it, and we try to print, right? So now
Mhm.
this L1 contains a list which contains like lot of different data types, and we are printing basically. Let's say print. So in Jupyter Notebook, the last line, if it could be printed, it would be printed. Okay, we don't have to print like write the code print every time.
Okay, okay.
Anyway, so this is our list, right? So let's say so L1 of 0. That is the first element that should be like giving us 1. Okay. The second element ABC. The third element is another list. You may ask me like, what if, sir? So basically, this is the third element. That is another list. So what if I want the first element of this particular list? How to fetch it? Correct. So then what you could do is you could do another square bracket and do it like 0. So this contains the second element of this first list one L1. This is the second index, third element. This is the list, and within the list, it goes for zeroth index. That is first element. Okay, so that is 1, right? So if I take 1 here, so in the first index, that is second element, it is 2, right? So now it should print 2. Understandable? So this is list 1. I'm referencing list 1, within which I'm referencing element in the second index. So that is index number 0, 1, 2. This is the second index, another list. So within this list, I'm indexing like 1. Okay, so it actually contains the second element, the 2, that is being printed here already.
Correct. Yeah.
Make sense?
And
Yes.
for the dictionary, the similar goes with the dictionary also. You have to pass the key rather than a
Yes.
index. You pass key there.
Yes, yes, yes.
Okay, okay, okay.
Yes. So let's try to do something now, something yeah, interesting. So let's, instead of trying to print the elements directly, we know it would be printed, obviously, right? So let's try to print the type of that element. Okay, let's say L1. So this should print, it's a class list. Okay. So here it
Okay.
is saying class of list, correct? Why? Because everything in Python is object, and
Is
list
object.
is also an object of list class. Correct?
Hmm.
That's why. So let's just say L1 of the 0, the first element. What's the type of this? Okay, okay, this is of integer type, right? One is integer type. So that's why it is one integer type. Let's say second element. Here it is string type, correct? So next, the
Yes.
third element. The third element is again the list, correct? Now we
Hmm.
go for like fourth element. Fourth element is a set, right? Next, the
Okay.
fifth element, it is a dictionary. Okay. So let's just say, so this is dictionary now. So we can operate on dictionary too, correct?
Yes.
So let's try to do some dictionary operations here. Let's just say
Uh,
putting up,
Arya, just a quick question.
yes,
All the primitive data types, they are also object, right? Like
yes,
int, uh,
yes, yes,
char, they are also
yes,
object
correct.
here.
Yes, yes.
In
So basically, this
Java, I
ABC,
guess there's a different concept. Java, they are non like primitive data types Java. So here
okay,
it's an object. Is it like
right, right. Yes,
okay,
yes.
okay.
So basically,
L-
this even the integer isn't object of integer class,
Integer
and
class.
string is
Okay,
an
okay.
object of
String
string
is
class
anyways
actually.
object. Yep.
Yes. So here L1 of four, that is fifth element, that is a dictionary, right? So we can directly do dictionary operations once we refer L1 of fourth index. Okay. Or let's say, so yesterday we checked on like a few operations that could be done on these particular dictionaries, right? Do you remember any? Manavin?
Could you repeat again? There's some voice disturbance.
Okay. Let's just say for dictionary, we did the few of the operations. Do you remember any operations?
Like
Oh,
add remove operations? Not sure.
Yeah. Basically, let's just say for a dictionary, let's just say this is our dictionary. Okay. Uh, when we say dict, okay. So these are certain methods which we can call for this dictionary data type. Okay. So it
yeah,
may be
yeah.
clear,
Clear.
copy from
Okay.
keys,
Yeah.
get, right? All
Correct.
these. So here I'm putting up, if we write keys here, this would actually print all the keys within that dictionary. That is ABC. In our dictionary, this is ABC, correct? Those are the
Yeah.
keys.
Right.
So now I am putting L1 of fourth index. Fourth index means fifth element, that is our dictionary. Now I'm
Mhm.
trying to print the keys of those dictionary. So now will it work? Integer object has no attribute keys. Just a second. So let's try to print the type of this. L104 is integer. Okay, we use some okay. Here, as you can see, since I run this cell, there is L1 variable, right? So it is referencing to this list. Okay, so that's why I couldn't do that operation. Let's just say I'm printing L1 now. So this is actually the list that is in this particular code block. Okay. but we are putting up L1 here, which is different. So we'll just rerun this. Now the L1 is reference to this particular new list. Okay. So now L1 of 4 is not integer, but dictionary. Okay. So we'll just try to, okay, this case, now this should work, right? So dict case has like name and session as two of its keys, correct? So this list contains different data types. And by referencing to those particular data types, right? So we are referencing it, L1 of 4, that is we are referring to dictionary. Now we can perform all the dictionary operations here. Understandable?
Yeah.
Yes.
This allows like whole set of new operations or we could do like completely off basics, right?
Hmm.
So this is essential to understand. So this is with the list, but let's just say let's do something interesting here. Okay, I will add up one more key called example, maybe. Okay, so this is the key. The value could be another dictionary, let's just say. Okay, and this
Hmm.
dictionary contains something called a message. So usually LLM responses are JSON format, as I said, right?
Yes.
So you must know how to navigate those,
Yes. The dot operator.
right? Messages. So now we go to like, let's say, hey guys, maybe how are you? Right. So let's run this now. So if we run this now, so there are three keys here in the list. Fourth index, that is the fifth element, that is dictionary. So the keys are name, session, and example. Name, session, and example. Correct. So let's just try to maybe put up like follow-up example. Example here, right? The spelling should be same. Yes, it is. So let's just run this. So now we are getting another dictionary that contains elements like
JSON
message.
object.
Correct. So here within the list, there is a fifth element which is dictionary. And within the dictionary, there is one element, it has got one element whose key is example, but value is another dictionary. Okay. So this is what nested dictionary means. So this is nested dictionary in action.
Hmm.
Okay. So here we are navigating to L1. So L1 is our list, the fourth index, that is the fifth element. Then we go to example key. So we have got this dictionary now. Now if we go to like, we'll put up messages.
Example dot message.
Right. Now this should print only the message. Hey guys, how are you? Correct? Here see how we are referencing.
Okay. Uh, can we navigate like how we write a JSON address like JSON path? JSON path
Uh,
must be like example dot message for this JSON. Is it
yes, we
work?
can definitely, yes, we can do that. No issues. So this is more like, let's
Array.
say,
It's more like an
there's
array.
another thing called get. Okay. So there is something called get in order to get the exact values for this particular
Mhm.
thing.
Okay, okay.
Where on this? See here. So this is L1 of fourth index, that is dictionary. And within dictionary, I'm accessing it as like, as we do like, let's just say in the square bracket, I'm writing the key, that is example. So it is going to example, no worries, right? And then I'm using operation. I could have again write this square brackets and would have written key, another key, that is messages. But let's say since this is the dictionary now, I can use the dictionary operation. That is, I have get. So I write it like dot get messages. Okay.
Mhm.
Now this gets this particular message. The same operation, just that the code is a little bit different. Okay. So yeah. So the nested dictionaries, nested list, they are very essential to understand, and it is very essential to navigate these things. Okay. So that's what I wanted to present you with this simple example. So how to navigate those particular elements if they are nested also. Correct.
With Olama, I guess we are mostly going to use this one, this data type. Is it
Is that correct?
with Olama? In our further practice, we will going to use tuples like with the user what we have seen example so far.
Okay, so basically role and the content,
Role,
right?
yes, content, yeah.
Yes, so that is essential when it is not particular to Olam actually. So let me show you guys. Okay, close the VS Code. Just try to open it. Okay, so what happening there was, so we are using something called Olama's chart object. Okay,
Okay,
so yeah, so this is our function, right? Ask LLM. So here, as you can see, this is Olama's class chart object we are using. That's why the response is in like object format, and that's why
format
it is
object.
checking if there is something called role in the message. Okay.
Mhm.
If not, if this chat method was sorry, if this particularly chat object was not being used, okay, it wouldn't have checked this. So that is the internal function of like how this chat
The
object is
chat object,
performing.
chat
Right.
method basically. Yes.
Yes.
Mhm.
Okay. So
Yes,
yeah, it
yes.
is as you can see here in the description. So we have to mention the model in the string format. So here this is pedantic. So it is suggesting that it has to be the name of the model should be present in string format, right?
Okay.
It is ensuring if not given, that should be denied. That is what like it is prerequisite of using this
Mhm.
particular chat object. Okay, chat method. Let's say.
Okay.
And for the messages, it is expecting something sequence. In a sequence, it is expecting. So here mapping means actually dictionary. Okay. So in mapping, what it actually means dictionary, and within the dictionary, the first element should be of string format. Okay, the second
Uh,
element could be of anything, any format, like it may be another dictionary. Let's just say.
okay.
Okay, whenever any is written, right? So it could be a list, it could be dictionary, or it could be another set. So if we want to mention like expecting only a list, we have to mention list here. If any is mentioned, we can use any of that, any of these data types. Okay.
Mhm.
Uh, yeah.
Message and the sequence is a array. Like when it says sequence, what is the
Yes.
sequence
Yes.
means?
Yes. So basically, maybe list of or tuple of elements, list
Okay.
of elements. That is a sequence, right? So there is
Okay.
an
This
order.
sequence is a method or something like I'm unable to understand what is sequence here. Yes,
So
this
sequence
sequence.
actually means, so they are using pedantic internally. Okay. So the pedantic
Okay.
sequence actually means some data type which has order, which could be like
Okay.
list,
Okay.
arrays, or tuple, anything such, which could be
Mm-hmm.
indexed. Okay.
Mm-hmm.
So that's why, as you can see here, so they have represented as list of, within list, there is something called mapping. Mapping means dictionary. Okay.
Okay. Okay.
They're ensuring this has to be the format in order to use this chat method. Okay.
Okay. And when we say pipe operator, is that means like or sequence of map is mapping string or any or messages or none? Is it a or
Yes.
here? Okay.
Yes. So these are other particular parameters we can pass, but yeah, this is not the necessity. So so when it says none, right? So if there is
Mm-hmm.
none, that's fine. Okay. But for the model name, it is showing it is not saying none, right? So we have to expect something.
Model has is a mandatory, I guess,
Yes.
to start.
Yes.
Okay.
Okay. So if you could go below, there is complete example of like how to use
Documentation.
parameters and what they actually mean. Okay.
Mm-hmm.
Right. So yeah. Sure thing. So that's about like navigating to things. So as of the indexing is concerned, let me show you the indexing in simple form. Sorry, slicing, right? So this is my L1. So if I print L1 now, so this is a list of like, let's say 111, 2, 3, 4, correct? So in slicing actually means, let's just say if it is, if there is a colon, okay? Left hand of the column, if it is empty, it takes like 0 as its element. Okay, basically. So if we just write it now, so left hand will be like minimum, the right hand would be maximum. That's why whole list is being printed. Let's say I'm cutting it to like maximum, it can go is 2. Okay, now you can see only 2 elements are being printed. that is 0th index, first index. Okay, let's say I'm putting up 3. Now only first 0th index, first index, and second index are being printed. Okay, so that is what slicing actually means. So let's just say say L2 is equal to this particular thing. Okay, now if I print L2, so it contains only the slice of this particular L1 list, right? So while if we reference L2 is equal to L1 and change some operation, do some operation is L2, that is reflected in L1. Okay, but when we do slicing and assign it, maybe the operations done here aren't reflected in the original list. Okay, L2 is gone, L2 pop operation is done. So now if I try to print L2, now this should contain only 1 1. Okay, earlier it was 1 1 1, correct? So one element is gone now. But if I print L1 again, okay, so this isn't affected by the L2 operations which we did. But if I try to do something like L2 is equal to L1 and try to do L2 operations, that is pop, now 2 is gone. Now I try to print L1. So here also 2 is gone, right? So 3 had, after 3 we had 2. Now 2 is gone. So this is actually referencing. We are creating another reference of the same variable, and this variable is reference to this particular list. So operations done using either of the variables should be reflected to the list directly. Okay. But when we do slicing, okay, when we do something like let's just say 1 4 maybe. Okay, let's rerun this. Okay, so this actually means, so I am seeking for 1 is here, right? So the first index, that is the second element, the third element, second index, the third index, not the fourth index. 4 is the limit, so I don't go to 4. So L2 should contain 1 1 2 now. Okay, let's just verify if it contains 1 1 2. Right, so L1 should contain everything. L2 should contain 1 1 2 only. Right. So what this is doing is, this is copying the list. Manogna, if you could remember, L1 dot copy we did, right? So that
Yes.
time whole list was copying, right?
Correct.
So similarly, when we do slicing and try to assign it to some new variable, so this is actually copying the things. It is not just referencing.
Right.
All right. So yeah, there are certain about the indexing. So it needs not to be like 0 1 2 3 every time. Let's just say I'm putting up -1. What this actually means is, sorry. Okay, L1 of -1. What this does is, it fetches the last element. Right. So 0th index is the first element, first index is the second element, second index is the third element, right? In -1. But this is called negative indexing, where if you put up -1, that is the last element. Okay. Let's say you are putting up -2, that is the last second element. Make sense?
Yes.
Okay.
Yes.
So we have something called step operation too. So instead of single colon, if we consider, so let's just say, okay, before that 0, 3. So what 0, 4? This should do is 0th index, first index, second index, and third index should fetch, correct? So 1, 1, 1, 2. These are the elements it should fetch, correct? It is fetching the same, correct? Okay. Now we have something called step function, okay, which works. So usually this step function, so we have to put up another column, and here whatever we type in, right? So that is the step function. So let's just say I'm putting up 2. Okay. So it goes to the 0th element. Next it adds 2 to it. Okay. So that is second index, that is third element. So now it should fetch 0, sorry, the 0th index, that is 1, and the third element, that is 1 again, right? And it can't go further 4. So this is the maximum it can go. Okay, it can go to third index, that is 2. But since the step operation is 2, it will only contain 2 elements now. Right? Is this understood, or are you guys confused? Maybe I will explain it with a pen. Just a second. Okay. So let's take on like what's happened there. Okay. So L1 is my list which contains like 1, 2, 3, 4, 5 maybe. Okay. When I say L1 of 0 to 4, okay, it actually means 0th index, first index, second index, third index, fourth index, correct? So when I say 0 to 4, it actually means 0, 1, 2, 3, but not 4. This is the end. This is the maximum. Okay, it has to be excluded. Okay, so whatever below it, 0, 1, 2, 3, that has to be printed. So when I print this, so the response is 1, 2, 3, 4, not 5, because 5 element is fourth index, correct? So the result of this is this one. Okay, but when we do the step operation, step function, okay, so let's say 0 to 4 again. So this is the result. Okay, when it is 0 to 4. By default, usually when we don't mention this, the step function, it is usually 1. Okay. So 1 actually means 0 plus 1. The step function is adding. Okay. 0 plus 1, that is first index. So that's why the second element is considered. Next plus 1. So now the 1 plus 1 is 2. So second index. The next by 3 is considered. Next plus 1. So 2 plus 1 is 3. Third index. 4 is considered. Next plus 1. But plus 1 is 4 actually. Okay. But 4 is excluded, right? That's why nothing is printed. So this is the list we get when we do this slicing. But we can change this step function. By default, the step function is 1, but we can change this step function as, let's say, 2. Okay. Let's say we default it to 2. Just write it to 2. Now what this does is, so it goes to the first element, which is being asked, that is 0th index, correct? So it fetches 1. Okay. Now 1 is within our list. And next it goes to step function. Step function is 2 this time. So 0 plus 2 is 2, correct? So now it goes to second index. It skips the first index. It goes to the second index. So now it's the element 3. So it takes in 3. Okay. Now it checks the step function. Step function is 2. So now it adds 2. So this is 4, correct? So it tries to fetch the 4, but the maximum is 4 and 4 is excluded. That's why it won't fetch the 5. It will end up the list. Okay. So when we use step function into slicing, so this is what happens. So by default, step function exists, but it is usually by default 1. Default value for step function. Okay, but we can change this. We can change it to like anything. Let's say now we are changing it to 3. Okay. Okay. So this is the list that we want. Okay. So now there is a list that's being created. 0th index. It goes to 0th index. We have 1 there. So we will take 1. Now 0 plus 3 is 3, correct? Now it checks the third index. There is something in the third index. It fetches it. Okay. Now it adds 3 to this because step function is 3. Now it tries to fetch the 6th index, but 6th index is not there. So it will just complete the list. Understandable?
Yes, yes.
Okay.
Yes,
Great. Manogna, are you clear with this?
kind of. I think I have to recheck again.
Okay. So yeah, so this could be like little confusing at the first
Mhm.
glance. But
Yeah.
yeah, once you understand this could be very useful later.
Okay.
Okay. So how this could be useful is, so let's say our list. Uh, so let's say again some list. This contains set of data types. Okay, a complete row 1, row 2. So let's say we are training a machine learning model. Row 3, row n. Okay, but this is of 1,000 rows. Let's say. But so some update comes in where the creator of this dataset says first 900 rows are good, but next 100 rows are actually garbage values. Okay. So in machine learning or deep learning, I have said it clearly. So if it is garbage in, okay, the output is garbage again,
Garbage. Okay.
right?
Garbage
So it
out.
is trash in, the output is trash out.
Trash
Okay.
out.
So we have to definitely exclude these 100 rows. We don't want to, so this is like poisoning, right? So we shouldn't do it. Only the proper data set, so that we need to have it, right? So by doing slicing L of 0 to 900, we essentially remove this 100. Okay. So I'm just putting up a practical example. Understandable?
Yes, yes.
Okay. All right. Or step function. Another example for step function is, let's say there are like n rows, and the creator of this data set says, so for every 100, particularly every 100 data set, so first 100, second 100, third 100, these are actually similar. Okay. Until the 1000, right? So 10, there are 10 sets of data. Okay. And every set has got like 100 similar rows of data. Okay. Now, if we try to train a model with this, so earlier first 100, there is some pattern found. So the model sets its weights and biases. Okay, its parameters, it sets it. But next 100 elements, they are completely different. Okay, training a model with such data is truly a bad idea. Okay, what we should do is we should consider random things from here, here, here. Since we know a detail that first 100 columns or first 100 rows are similar and next 100 rows are similar, what we could do is list of, let's just say 0. Maybe what we could do is for I in uh, range of 1, range of 0 to 10. Okay, what you could do is list of I. Okay, so here it could be like 900, right? 900 is our maximum thing. Okay, then what the step function could be 100. All right. So what it does is, so initially I is 0. So range of 0 to 10 means, so this basically creates a list of 0, 1, 2, 3, 4, 5 up to 10. Okay. So for the first iteration, I is 0. So this essentially becomes L of 0 to 910, right? So this will take up one example from this set, the second example from this set, third example from this set. So it creates basically 10 rows of data, which is completely different. Okay. From each set, it will take up these examples. And in the next iteration, I becomes 1. Instead of 0, this becomes 1. Okay. So Manavna, if you just go through for loop, how it works, maybe you can understand this better. As of now, just wait me for like a few minutes. Okay.
Yes, please. Yeah.
So now in the second iteration, once I becomes 0 and does this operation, whatever the operation that's been given, I becomes 1 again, because it has to go to 0, 1, 2, 3, 4 until 9. 10 is the limit, so 9, correct? So I becomes 1. So now L of 1. So it takes the second row of data from this 100 set. Again, the second row of data from next 100 set, because 100 is our step function. Understandable? Guys, what's happening? Is it understandable?
Yeah.
Sure then. So that's the like straightforward example for using these slicing techniques. Okay, why to use step function and why to use this slicing technique anyway, right? So yeah, so let's try to understand how a looping statement, let's say how a conditional statement works. Okay, we have to go through this file structure. So there are conditional statements like if statements. Okay, now there are else statements. Now there are like finally block. We have try. We have except block. Okay, except and try. Except try and finally. So these blocks are bit advanced. We don't use it at basics of Python, but these are essential to create any Python functions. Okay, to create a foolproof Python functions. So let's explore this. What are if-else function? So Manavnya, what happens is, if a if statement is written in a Python, so if this is a keyword, okay, so it expect a condition. It expects some condition. Okay, if the condition is true, the code within this block. So there would be a like code written here. Okay, within the if statement. Okay, that will be run. If the condition is false, okay, this code won't run. Okay, let's just say, let's take a practical example. If Rahul wears shoes. Okay. If he wears shoes, he will run. Okay. If Rahul doesn't wear shoes, so that is a negative condition, right? So false. Then he won't run. Okay. If let's just say thunder is one, print, it rains. Else, print, it's sunny. Okay, let's take up this particular example. So here basically this is the code. Okay, so we have a if condition. So we are writing up if within which we are putting up a condition. Okay, so we are checking if there is a thunder. If thunder could be any variable. Okay, so if thunder is true or one, okay, one and true are same. Zero is equal to false. Okay, when we say zero, it means false. When we say false, it actually means zero in Python. So whenever we say one, it is true, and if we say true, it could be considered like one. Okay, they are interchangeably that can be used. So if there is thunder, if this thunder is equal to one, correct? So then we can say it rains. Okay, then this would be printed. Okay, if there is no thunder, okay, this thunder would be like zero. Zero is not equal to one. So then this won't be printed. But what it could be printed is if statement doesn't run, if there is else statement, this would run. Okay, if else combination is such a way that if and else, either one of these will run. If it happens, if the condition becomes true, the code within this if statement would run. Okay, if this doesn't run, for some case, if the condition is false and if doesn't run, then else will run. Understandable, guys?
Yes, yes.
Yes, yes.
So, yeah, we will just take up a simple code to better understand the same. Okay. Let's just say, yeah, thunder is equal to false. So now if I'm checking if thunder, it's a condition, okay? Condition we need to do. So if thunder is equal to 1. So this is the syntax, okay? If conditions are written like if within brackets, we need to write up the condition and then colon, and every time in Python. So this index, you can see a gap, right? So let me just type it. It's visible now. It rains. Okay, you can see the gap, right? Within from thunder to if, there is no gap, correct? They are just below it. But after the if statement, there is a gap for the print statement, correct? There is some space, empty space is given, correct?
Right.
So why that empty spaces means? So we are essentially saying saying it to Python that whatever that is being written with this spacing, right? So that actually comes under if.
Mm-hmm.
Okay. So let me just copy the whole thing. Try to create one more code where this is true. So thunder is my keyword. Okay, it's a variable. So for that variable, I'm putting up false. Okay. So let's just run this and then understand like. So yeah, let's just run this too. So both run, right? So here in the second element, it said it rains. Something is printed here. Here nothing is being printed. Why? So because thunder is true here. True, I said true is equal to 1, correct? So that's why 1 and 1 got compared. So 1 and 1 is equal to 1, correct? Mathematically correct. So that's why this become a true condition. Okay, as you can see here, true is being shown, correct? So since this become a true condition, condition passed, it didn't fail. That's why this print statement ran. Okay, here if you can see false. False is 0. 0 is not equal to 1 in any mathematics. 0 is not equal to 1, correct? So that's why this condition failed. So if condition fails, the code which is written under if statement, it doesn't run. Okay, understandable?
Yeah.
Yes. maybe let's put up like another statement else. I will print like it's sunny. Okay, let me run this now. So the output is it's a sunny because the if condition is not being so this condition is not true, correct? So 0 is not equal to 1. False means 0. So I can write like 0 here, and this would be simply the same. Okay, false means 0. So 0 is not equal to 1. That's why it didn't run. This statement didn't run. So it runs, it didn't run. And what it ran is, since if statement didn't run, the else statement will definitely run. Okay. So that's why it's sunny is visible here in the output. Okay. Now if I type up like else statement the same here, else print, it's sunny. Okay. The same code, correct. Now here it rains is printed. So this code run. Since this code ran, else is ignored completely. Okay. Make sense?
Yeah.
Uh, maybe another tricky. Let's. It's still raining. I'm bad with the examples here. Okay. So let's just run this. So as you can see, under if block, there are two lines of code, correct?
Mm-hmm.
And for both the lines, there is some gap index here, correct?
Mm.
These lines actually follow the same path, but within the if statement, correct? So this actually means, so whatever the code that is influenced by the if statement, correct? So we have to write it under the if statement. If I give space here again, let's say I'm putting up some more space, this would throw me an error. Okay, why error? Because here it is not an if statement, or this is not any conditional statement, or this is not any looping statement. So why the space is given? So the Python considers the code based on the spaces that's provided.
Mm-hmm.
Okay. So that's why the same space has to be given. So this actually means within the if statement, there are like two line of code. Okay. So you can type up like n line of code, nothing is wrong. Okay. It's still running, it's still running. Okay. Right. So let's just say within if statement, I want to create another if statement if the thunder is, let's leave thunder for now. Let's say rain. Okay, let's say rain is equal to 0. It is not raining. Okay, it's thunder. So let's say rain is equal to 1. It is true now. Okay. Instead of here in the if statement, let's just say rain is equal to 1. Then print. Don't laugh at my print statements, please. It's raining hard. All right. And now we'll type up another else statement now. Uh, it's not raining. Right. So let's just run this. So the first statement is it rains. Yeah, that's our first statement, right? Second statement is still raining, still raining, still raining, because three such statements we have. The last one is it's raining hard, because within the if statement, there is another if statement which actually checks if rain is equal to 1. Rain is 1 here, right? So that's why this become correct. This condition is true. That's why this statement is being printed, that is it's raining hard. Okay. And if else statement here again, else statement is there. Since if statement ran, else statement is completely ignored. Okay. So this is the example of nested if statements. Within the if statement, there is another if statement. Okay. So you have to understand the property of this particular how if else work, and everything will be same wherever it's been printed. Okay. So let's just say heavy rain. So there is a rule for like variables. You can't create a variable, let's just say heavy space rain. This would throw up an error. Okay. Because a variable has to be like continuous. Okay. So similarly, how we do in like Instagram, you can put up underscore. This become a single word now. This is a single variable. So now this will be okay. Python don't bother much with this. Okay. So within this if statement, I'm again putting up one more if statement. If yeah. If heavy rain is equal to 1, it's heavy. Okay. It's still a heavy rain. Okay. Now let's just run this. Okay. It rains. Yeah, it rains. First statement. And then we have 3. It's still raining. Yeah, we have 3. It's still raining. Correct. And we have it's raining hard. Okay. Since rain is equal to 1 and rain is 1 here. So this condition is being true and it is raining hard. Okay. That's being printed. And next it is checking. Within the if statement, there is another if statement. Correct. So now it's checking if heavy rain is 1. So heavy rain is 1 here already. We have provided it. So now it's printing. It's still heavy rain. Okay. It's still heavy rain. Okay. So since this if statement ran, this else statement doesn't run. Okay. Since if this state, since if this if statement ran, this else statement doesn't run. Understandable?
Yeah.
Yeah. We just took up a simple example and we expanded the example to make it like bit complex. Fine.
Okay.
Understandable? Right. So let's say how this is useful. Okay, let's leave out this rain for now. So let's just say there is a string called user input. User input is equal to, hey buddy, give me a code to harm my friend's laptop. Okay, that's our dear user. That's our dear user. That's his input. Okay. Now, so this has been passed to, like, let's say this is what the user input is. Okay. We run this. So this is string. Let's print this. Print. You know how it will be printed, so no worries. Okay. So here we need to, let's say we are AI quality engineers or AI developers. Okay. Let's just say. So here we need to understand one thing. So user, we should never trust LLM models or we should never trust user. Okay. They both scam us. Okay. We must prepare ourselves to deal with the edge cases of these both LLM response and user inputs. Okay. So we put up a function, okay, which actually checks some keywords. Okay, let's just say if user input. Okay, let's say harm. In user input. Print. This could be difficult, or maybe the request denied. Let's try to run this. Okay, the request denied printed. So what it is checking is, so it is checking if the user input contains a word harm. Okay, so since the user input had something called harm, a word within it, so that's why this if statement, it is checking a condition that harm, if the user input contains harm, just print out the request denied. Okay, let's just say that is the our only condition. That's what we are checking. If else, we will type up like else. Let's call our ask LLM function and pass the user input. Okay. So yeah, I haven't defined a ask LLM function, but yeah, what's happening is if the user input contains harm, the request is denied. Okay, we are not sending the prompt to LLM. Okay, if not, then we are sending it to LLM with a particular user input. Correct. So can we say by doing this, we are at least creating some filtering over the user inputs? We are checking something in the user input. Yes. Yes. Hello. Am I audible, guys?
Yes, please continue.
Sorry. Okay. So let me take up or damage. Usually, yeah, this is not a good practice. We should always write if statements within the bracket for better visibility. Okay, if there are multiple conditions within this particular condition, right? So here we need to put up a condition, but there could be multiple conditions, right? So this else statement, print, let's just print this whole thing. Since we haven't defined ask LLM function yet, so it would throw up an error. So that's why we just print this. We are running it. Yeah, request denied since it has harm. So instead of harm, if it said damage, then also this function would have recognized the damage and would have said the request denied. Understandable? So you can put up list of the words. Let's just say you Google the list of words which are into malicious prompts. Okay, you would get like 100 to 1000 of words. So you can put up in a list all those words in a list, and you can put up a simple if statement and check if any of the user input contains any of those 1000 words. If yes, just reply user denied. Okay, the request denied. Or else, then you can pass it to LLM. By doing this simple thing, you are actually creating a certain level of filtering. You are filtering, you are verifying the user input at the base level. Okay, understandable? Does that make sense? Why if statement or else statement is considered necessary?
Yes. Yeah.
Yes, right. So yeah, we will check on like one more thing. So this is conditional statement, that is if condition. Okay. So within if statement, another if statement could be there. Within if statement, there could be another if statement and else statement, and there could be something like okay. So just okay, let's take this, and instead of I'll just remove this. This is our earlier code, right? Now I will go to like another if statement I have write. So this is one more thing I have to show you. Paste the whole thing. Okay. So here, instead of checking for harm, let's check for damage. Damage in user input. Print the request denied because of damage. Okay. This could be as of harm. All right. So yeah. Now let's just check on like how these conditions work now. I'll just run this. So you can see the message, the request denied because of damage, correct? So this if statement is checking if the user has user input has harm in its statement. So there is no harm here. So this code isn't run. Okay, this print statement was skipped. Understandable? Then there is another if statement. Okay, now this if statement runs, and if this if statement is checking if the user input contains damage word. Okay, since it has damage word, now this if statement run and the request denied damage. This got like printed. Correct? Now let's just say not there is no damage or hurt, sorry, harm in my input. Then what's printed? Ask LLM user input. Okay. Then we can say go for like this is else statement. Since both the if conditions failed, okay, whatever if since both the if conditions failed, the else statement actually ran. Right? The code within the else block actually ran. Understandable?
Arya, so what is the point of asking ask LLM, because we would have given uh, some other text in the else, right?
Yeah, we could
Asking
have like so
usually we are taking help from LLM to operate this function.
not actually. Let's just say so by essentially checking this, what we are achieving, we are at basic level, we are filtering the user inputs considering the severity of like the words used, correct? Okay, so there is a malicious statement. Malicious user is putting up some statement. Okay, maybe
Correct.
having a computer or damaging it or creating a virus or something like that. Okay,
Right.
so here in these codes, we are actually checking if any of those words actually contain in the user input. Correct?
Mm-hmm.
If it is content, we are denying the user request. Okay, well,
Right.
this is not the exact statement we have to print. So this is for example. We may take
Yes.
some actions here. We may note
Right.
down basically the user details, who has put such the IP
Mm-hmm.
address of that particular user or the account details. All
Mm-hmm.
those things we record in ideal situation. Okay, since this is an example, I'm just printing a statement that user denied. Okay,
Mm-hmm.
so if all these if statements, there could be hundreds of if statements, or there could be a single if statement which contains a list of words, and we are checking the user input against all those words. Okay. Once this if statement is not run, what it essentially means is the user input could be safe. Correct? I'm not saying if it is safe. I'm saying it could be safe. Correct?
Mm-hmm.
So then this is an example. Okay. So if the user input is safe, then else statement actually runs. Correct?
Right.
Correct. So within the else statement, we can write up a function which actually calls the LLM, or write up a code which actually performs this operation of sending this user input to LLM. Since we don't have that function here, I'm just printing ask LLM user input. All
Okay.
right. So this is just for like example, mock example.
Okay. Okay. Yeah.
Yes. So if we had something like so in the VS Code, so here we have like something called ask LLM, correct? This function.
Mm-hmm. Mm.
We would have, instead of printing this particular statement, we could have called directly ask LLM message, and
Right.
then
Right.
the LLM response could have been gained, right? Does that explain your answers your doubt?
Yes. Yes.
Oh, great. So yeah, let's just finish last topic. Maybe for loops we can go for. Okay, we can understand other looping statements tomorrow, but let's go for like for loop now. So how
Okay,
for loop
okay.
hoops? So all these looping statements, right? So leave about loop for loop. So we have something called looping statements in Python. Okay, what these does is there is some code. Okay, let's just say the code is print am area. So that's a simple code, right? So print area that could be happened. So let's say I have to do the same operation for 100 times, or let's just say 1,000 times, or maybe more than that. Okay, so so ideally, so as we know Python now, so what we would do is like write up print within the print statement area, correct? So I'll just copy this whole thing instead of typing it again and again. So paste, 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 paste. By running this block, now I can print am area for 5 times, correct? So basically, I'm doing a simple, straightforward, a single operation, but I'm repeating it. But let's say I have to do it this for like 100 times. So writing up these print statements 100 times is not like it would be a lot more of a manual work, right? So instead, what I could do is I could use a for statement here for I in range of 0 to 100, let's say. Okay. 0 to 100 print time area. So let's just run this. So now this prints area for like 100 times. Am area, the same operation.
Uh,
So
Arya, do we not need to increment this I in for
yeah, that's
loops?
been no, that's not needed because when we say range,
Okay,
correct?
okay, okay.
When we say range, it actually creates internally, it creates a list which
Range is a
contains like
method.
from 0 to 99.
Range is a method, right? If I'm not wrong.
Yes, yes, yes.
And range is a method of which class?
We don't call it like a method.
Okay,
So
okay.
let's call it more of a like
Keyword.
um, yeah. It could be range is an object actually. So here you could see. So it's a range object.
Range
So
object.
there is a class called range. and there is a within that class there is something called object, range object. Okay.
Okay.
So that is being written here. And as you can see here, the first element in within the range is the start index. Sorry, the start of that particular whatever the range should be. The second element that needs to be provided is basically the last, the maximum. And the third element is step. Step is not particularly like compulsory. So here I have not put up step. So this actually means step is by default 1. Okay. So if I write up like 1 here, this doesn't change anything. But if I write up like 50 here, so just check this out. Okay. So array is only 2 times now.
So it
Because
jumps
0 plus
twice, like first is 50, second is 100.
yes.
50 steps,
That's right.
it's jumping 50 steps.
Yes, correctly.
Okay.
So 0 to 50 step means 49, correct?
Yes.
And then 0 to 49, 0 to 49 if you could count 0, 1, 2, 3, 4 such. So that would be like 50 steps. And then 49 to 50 is again 99. Okay. So 99 is still within 100, right? So that's why 2 times it printed. Okay. Let's just say I'm putting up like 51 here. So this would print only, okay. So 52. So this would print
Step
only.
is default 1.
Oh, all right. So what it does is, so at 0, it actually prints something, correct? Amaria. That is the start.
And then 52,
okay.
51.
Yes, and then 52. That's why at the second time it printed, not the third time. Let's say I'm putting up something like 49.
49.
Now this should print like 3 times.
Okay.
Understandable?
Yes.
Let's say 25. Okay.
4 times.
Now this should like 4 times. Correct. So by default, this step is 1. So that's why I becomes 0 first. Then I becomes 1, I becomes 2, I becomes 3, and so on. Okay. Even though if I change I here, okay, this is interesting thing in for loop, and it's not like while I was exploring Python on YouTube and everything. So this wasn't told by anyone. So it actually you get to know this once you try to experiment with Python actually. Okay. So let's say I update I is equal to I plus 10 here. Okay. So now what this should do is by default the function is 1 anyway, correct? So I is 0 first time. So by essentially by doing plus 10, so I should be 11 second time, correct?
Yes.
Let's also print I here for better understanding. Okay.
That I have.
So before this particular thing, if I run this, so I is like from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this is of 100 time 99. 0 to 99 means 100, correct? So now let's just print this I is equal to I plus 1. Okay, I plus 10. So this should only print 10 times. So as per the logic, correct? As we understand, since I is being incremented. But as you can see, so this doesn't affect this particular I, because the I within the for loop is completely different from the I that is being used within the the code block within the for loop.
Okay. Can you swap the positions? Print after the I equal to I plus 10.
Yeah, so this prints every time. So yeah, let me just print this one too. Okay, so what it's doing is, so yeah, I is being updated, no worries. But the I within this for loop is different, and the I that is being created here is different.
Okay, the scope changes.
Yes, basically, so here that's
They are
why
not the
I'm
same
Arya.
I is not the same object for loop and inside the for.
Yes, so what's happening
Okay.
internally is, let me try to explain it theoretically. Okay, let's just say we have a memory block. So this is my memory block. Okay. So when you say for loop for I in range of some 0 to 100. Okay. So this actually creates a complete memory block where 1 to 100 is being already written. Okay. Now this I is only referencing this particular list. Okay. When within this for loop, if you write I is equal to I plus 10, so this I is equal to I plus 10 is being created somewhere else. Okay, it is not disturbing this particular whatever the memory block that's being created. So this I plus 10 is happening somewhere else. So initially I is 0. So 0 plus 10 is 10. So 10 somewhere else this I is being like referenced. Okay, the next iteration I is 1. Here the I is 1. Correct. So this 0 is done. So it goes for 1. So when I is 1, so I plus 10 becomes 11. So somewhere else, this new I is referencing to 11, but in somewhere else. Okay. So the loop is iterating over this particular memory block, and this doesn't affect. This
Yeah,
isn't
Arya,
affected by any operations that's been done under the for loop.
is the I default initialized by 0? Is that true? The I
Yeah.
default, the second I,
Yes.
not the
Yes.
for I.
So
Okay.
let's say if I don't give like a 0 here. Okay.
Hmm.
So then again, as you can see, I is 0 first. Correct. So if
Okay,
you
okay.
directly give range.
So
So let's
Python
say I'm
default
printing a 5.
compiler default initializes the data
It's a minimum, right?
data types.
So first one is
Okay,
minimum.
okay.
So it considers 0 to be like minimum.
Hmm.
Okay. So now I'm saying like minimum has to be 5, not 0. Okay. Now, as you can see, the first statement printed is I'm area 5. Right.
Okay, okay, okay.
So from the 5 it is starting and it is ending at like 99.
Okay.
Understandable? Yeah. So this the operations that's being done under the for loop. Okay. This doesn't affect the actual for loop that is being iterated over. Okay. Understandable? Manoj? I guess you got confused here a bit. Okay. Correct?
Yeah, fine, actually.
So basically what's happening is, so there is I, okay. So usually in for while loop and everything, we will explore while loop tomorrow. So there, if we write something like under the while loop, if we update this particular variable, that updates. And while checking for the while condition, if that becomes a condition that could be true, while it runs or else while doesn't run. Okay, tomorrow we'll explore about it, explore on it. But so what we need to understand is, so the variable that is being defined here in the for loop, okay, for I in range of 5 to 10. And yes, this is a variable. So you can say ABC here. Okay, nothing changes. Okay. So here ABC is in range of 5 to 10. So now earlier I was last 109, right? So that's why 109 is being written here. Okay, this was for earlier code. Okay. So in okay, let's just remove this. This is config. This could confuse you guys. I'll just remove this too for better understanding. Yeah. Okay. So I is simply a variable. It is not something that has to be used for loops. Okay. I'm using ABC now. ABC in range of 5 to 100. So now ABC is referencing to 5, 6, 7, 8, 9, 10 as. So when it is referenced to 5, this particular code within that for loop, it could be 1 line, 2 line, 3 line, 4 line, any number of lines. Okay. All the code that is within this for loop that is being run. And then this ABC is updated to like next digit of 5, that is 6. Okay, now ABC is 6. That's why when this run for the second time, I actually printed I'm area 6, correct? And then after the 6, it goes for 7. Okay, so everything under the for loop runs once the ABC get updated. Okay, 5, 6, 7 times. So by putting up like a 5 to 100, we are essentially saying from the 5, take up 5, then go for 6, 7, 8, 9, 10, and so on until you get 100. Once you get 100, stop the execution. All right. Understand what it is?
Yes, yes.
Yeah, we are going over the time. I guess we can end the session for today.
Sure,
And
sure.
as of this point, any doubts until now?
No,
No, nothing from my side.
Management?
Nothing from my side.
Okay, right. Saurabh, any doubts?
no, 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 no.
Okay. Please go through. Please try to practice over this. Please try to experiment over this. If you get any doubts, please refer me. Okay.
Okay.
We can ask those doubts tomorrow. Please try to experiment with this Python. Okay.
Okay.
Mm. Thank you.
So then,
Yeah,
so Saurabh,
happy we
you
can.
want me to share that particular notebook?
Okay, okay. But it's fine. It's fine, Arya. I see the examples can be generated by what is called
Yes,
Gemini.
yes.
It has an
Right,
integrated AI there.
right. So that could be like simple. And I'm also using it
Yes,
as a
yes.
scratch file, not a notebook.
Uh,
So I mean,
yes, yes, yes.
not continuous notes.
Yes, yes, yes. It's fine. It's fine. No need to share. To share.
Okay, great then. Sure. Have a good evening, Saurabh, and have
Yes,
a good day,
yes, yes, yes,
Manamna.
Thank you. Thank
yes,
See
you.
ya.
yes, yes. Bye, bye.
Happy weekend. Bye.
Yep, you too.